18.1, 18.3, volume of prisms and cylinders, and then volumes of cones. The former 18.1 you might have had in junior high, but cones might be newer to you. All right, here's a right prism. That means it's got some right angles here, 90-degree angles, and again a right cylinder, which means this angle down here to the base is 90 degrees as well. If you'd like to put that in your notes, go ahead and pause it, and when you're ready, go ahead and hit resume. Okay, here's the formula for the volume of a prism. We've got length times width times the height. I'm going to give you a different one here shortly, but here's the basic one. The volume's length times width times height, something you remember. And again, this is length times width times height as well, but because it's a cube and all the sides are the same size, we can just denote it as s cubed. Go ahead and copy that down and pause it if necessary, and hit resume when you're ready. Another way to think about it is you've got the base down here. It's the same as what you see here. Okay, you've got your base, and your base is equal to your length times your width. So to get the volume, you're just going to stack a number of these bases on top of each other. That's how you get your height. And so basically, I like looking at the volume of a prism and most other things. The volume is equal to the base, which is a big B, times the height. Okay, so volume is going to be the big B, and again, this is two-dimensional. It's length times width. Okay, and then you've got your H, which is your height. Okay, it's a little bit different than doing the volume is equal to length times width times height. Basically, the length and width are going to be your big B, or your big base. And if you look at that with most things, especially when you get to a cylinder, you get the base. The base is a circle. So if you know the formula of the circle, that's the big base, and then you just multiply it by the height. And then you've got the volume. So in our first problem here, finding the volume of this shark tank or whatever it is at the aquarium museum, if we look at volume as being length times width times height, and you can think of it a different way. You got your length, your width, and your height. So you got your length of 120 times your width of 60 times your height of 8. Okay, and that's how you work it out. If you're looking at the big base, volume is equal to the big base times the height. The big base is going to be your length and your width. So you've got your big base being 120 times 60, and then you multiply it times your height, which is 8. So either way, you're going to get the same result. It's just a different way of thinking about it. As far as if you forget what the formula is, you could think most volumes are the big base, so you look at what the base is, and in this case, it's a rectangle. It's a 120 by 60 rectangle. Then you must multiply it by the height. Okay, you multiply those three together and you get that. Of course, you're saying, well, this is high school, Mr. Lentz. This is just like way too easy. But what this is going to ask you now, what I'm going to ask you is, now find or estimate the volume of water in gallons. Okay, and if 1 gallon, okay, and we're going to use this conversion factor, 1 gallon to 0.0 or 0.134 cubic feet. And remember, when we're using volume, we're doing it in cubic feet. So if we're going to use this conversion factor, then we're just going to multiply the 57,600 cubic feet. And we're going to multiply it by that, canceling out the gallons, which gives us, we just divide that by 0.134, and that gives us 429,850 gallons of water. Of course, then you can figure out the weight of the water also, which there's 8.3 pounds per gallon. Okay, so let's go ahead and do that. 8.33 pounds per 1 gallon of water. Okay, so we're going to go ahead and multiply this times that, 429,850, and we're going to get, basically when we multiply that, it's going to become a huge number. it's going to be 3,580,659 pounds of water in this aquarium. Of course, we have a cube here. You want to find the volume. That's easy. So side cubed, 3 times 3 times 3 is 3 cubed, which is going to equal 27 centimeters cubed. Again, the cubes. Then you can use all types of physics in this and estimate the volume of water once the ice melts, because ice basically takes up more volume than water, so you'd convert the mass using a convert the volume to mass using the physics conversion functions, but we're just concerned about some formulas right now. So let's get on to a cylinder, and I showed you a right cylinder before. And again, for a cylinder, basically your base is equal to a circle. Okay? So you just have to find out what your big base is. Again, the volume is going to be your big base times your height, just like we had for the prism. But this time, your base is going to be a circle. So your base, your volume is going to be pi r squared. So technically, you could say your volume of a base is going to be pi r squared h, or you just look at your big base, which is going to be your pi r squared because it's a circle, and then you just multiply it by your height. If you memorize this one, big base, whatever the base is, and just multiply it by the height, it's going to help you out several different formulas, at least figuring them out. Now sometimes those aren't as easy. Sometimes those are right prisms and right cylinders. Sometimes you're going to get what we call an oblique prism. Now, it doesn't change anything. Again, you take the base and multiply it by the height. Again, the base is a circle, multiply it by the height. Doesn't matter if it's oblique or if it's right angled, like the first examples I gave you. You still do the big base, which is a rectangle or square or a circle, and multiply it times the height. So now for our problem here, we need to find the volume of this composite figure. We've got a prism with a length of 12, a width of 6, and a height of 14. And then we've got a cylinder stuck on the end of it that's got a height of 4 and a radius of 4. So what you need to do is find the volume of this, and then you add it to that volume. Go ahead and pause the video, work that out based on your formulas, and hit resume when you're ready. Okay, there we go. We find the volume of the cylinder, which is pi r squared h. We know that 4 squared is 16 times 4 is 64, so now we have 64 pi. That's the exact answer, or we can convert it to an approximate answer, multiplying times pi, which is 201.06 cubic feet. And then, of course, the prism is length times width times height, or the big base of 12 times 6, that's the length times the width, times the height of 14, gives us 1,008. We add those two together, 201 and 1,008, to give a total volume of 1,209.1 cubic feet, rounding it to the nearest tenth. Okay, go ahead and go to do lesson 18.2 and 18.3 along with this as well, because I talked to you about the big base times the height. And a pyramid is 1/3, that's the way they come up with it, 1/3 of a prism. So you just got the volume is base times height for a prism, you just take 1/3 of that. Same with a cone, it's 1/3 of a cylinder. So if you got the volume of the cylinder as a big base times the height, you take 1/3 of that and you get the formula for the cone. And again, the big base on here on a cone is a circle, which is pi r squared. The big base on this is a rectangle or square, and you've got length times the width. So you just determine your base for a pyramid and cone, and then you can determine the volume, and we'll go ahead and set a couple examples here. So let's say we have, on this pyramid, we got the height, and the height is at a right angle here. We've got a height of 16 centimeters. Then we've got this length here is 24 centimeters. And we've also got this one is 24 centimeters, which means it's a square base. So then all we have to do is multiply 16 times 24 times 24. 16 times 24 times 24. And we get 9,216. But we divide that by 3. So we've got 24 times 24 times 16. And we take a third of that. So a third of that. And we've got 9,216. Sorry. And a third of that's going to give us 3072 cubic centimeters. Okay, moving on to the pyramid example here. Sorry, I meant cone. It's not a pyramid. That's the pyramid. Here's a cone. So let's say we have this distance here, and we're looking at the diameter. Let's say the diameter is 2.2 inches. And then we've got the height here of 1.8 inches. And again, we need to figure out the big base. Again, 1/3 big base times the height. That's going to be our volume. So we take 1/3 times the big base. Now, the big base here is a circle, so we need to do pi r squared. Pi r squared. Sorry, let me move up here. And then times the height. Well, we already know, got pi. We know our diameter. Our diameter is 2.2. Well, 2.2, we only need the radius. So the radius, half of the radius is going to be 1.1. So we've got 1.1, and we have to square that, and then multiply it, and we already know the height is 1.8. So go ahead and figure that math out real quick. Multiply 1/3 times pi, 1.1 squared times 1.8. And go ahead and hit resume when you're ready. Okay, here's all the work. 1/3 pi times 1.1 squared is 1.21. The height is 1.8. Square, you already squared that, sorry. Multiply these two together, 2.178. If we take a third of it right now and just leave it with pi for an exact answer, the volume would equal 0.726 pi, inches cubed. But if we want to estimate it, then we take the 0.726 and multiply it by the pi function on our calculator, and that will give us approximately 2.28 inches cubed. Now, if you had put 0.726 and you did just use the 3.14 for pi, you're going to get 2.279, which rounds again to 2.28. Okay, now for our last problem, number 6, we're going to do a composite figure now. This time dealing with a cylinder and a cone, and they're on top of each other, so it's 1 unit. It almost looks like a crayon. But the entire length, or the entire height of this whole figure is 32 millimeters. The height of the cylinder is 19, and of course the diameter, which is also the diameter here, okay, is going to be 16 millimeters. Go ahead and pause this and work everything out and see what you come up with. I would take and find the volume of the cylinder first. Remember, you have to take, for the radius, you got to take half of this diameter, which is going to be 8 millimeters. Okay, and find the volume of the cylinder, and then notice the base of the cone is going to be the same as the base of the cylinder. It's the same diameter. So now you've got that. The only thing is you have to subtract 19 from 32 to get the height of the cone, and then you had those two together. So go ahead and hit resume when you're ready to go, or you can hit resume and watch me work through it as well. Okay, we find the volume of the cylinder first, and again, it's the big base times the height. The big base is a circle, pi r squared. We know if the diameter is 16, then the radius is 8. We square 8 to get 64. 64 times 19, and then times pi is going to give us 3820.176 repeating. And we'll change that to 1.177 to the nearest hundredth. Our cone, now we need the volume is 1/3 the base times the height. Well, we already know the area is the same, so that's going to be pi times 8 squared. This time we have to figure out the height though. So we take 32 and subtract 19, because if the total height from here to here is 32 and here to here is 19, then this height right from here to here has to be equal to 13 millimeters, which we figure out by subtracting 19 from 32. Now we substitute in 13 for our height, and then multiply 8 squared, which is 64, times 13, take a third of that, and then multiply it by pi, and we're going to get 871.268. We add those together, round to the nearest tenth, and we got 4691.4 millimeters, cubic millimeters, or millimeters cubed. And that's it. We're not going to have a ton more examples, just to introduce you guys to volume, and then we'll move on from here. But that's it for this lesson.